Hi, this is Jeff Geisinger, and this is the fourth DIVA tutorial, and in this tutorial I will be going over how to apply dynamic shading, and we will run an annual glare analysis to see how the shading affects the annual glare for the space, and we'll also run a daylight autonomy calculation in order to see the trade-offs for interior daylight levels as a result of the shading. Again, as with the other tutorials, we'll be using the reference office, which is a south-facing side-lit office with the shoebox geometry. And the Rhino file for this reference office can be downloaded along with this tutorial. To begin, I will remind the listeners about the local project directory and the subfolders in that directory. This local project directory is located in a folder that is automatically generated by DIVA in the location where you have your Rhino file saved. And since I saved mine on the desktop in a folder called Reference Office, it is located right here, and I'm inside this folder, and I have these four subfolders. And I'll go ahead and click on grid-based. So if you'll remember from the previous tutorial, or the second tutorial when I ran a daylight autonomy calculation, we automatically generated this HTML file, which is a DASIM report that summarizes the results of the daylight autonomy in the space, along with other information about the lighting performance of the space. So I'll double click that to open it. And I'll resize this window so that it fits in our screen. So you'll remember that there is information about the daylit area in this report, and also we had seen a line item about glare, and we didn't really go into any detail about this, but the report listed the amount of glare in the entire space, the amount of occupied hours that are experiencing a perceptible or worse level of glare, and that was 16.7% of occupied hours. And the reason why this report contains this information is because I had previously run an annual glare calculation similar to what we did for tutorial 3, and that automatically generates a daylight glare probability file, and this DASIM report reads that file and it gives you a percentage of occupied hours that the space, that specific viewpoint within their space that is based on the camera angle that we used is experiencing perceptible or worse levels of glare. And what we'll be doing is we'll be applying a dynamic shading to the south-facing window. We'll be applying a Venetian blind system in order to improve the glare, or in other words, reduce the level of glare, to reduce these occupied hours. But also, we'll take a look at how this can be visualized in an annual glare map that DIVA automatically generated when we ran our annual glare analysis in the third tutorial. And so that's also located in one of the subfolders of our project directory. If we go back to the main local project directory, you'll see that I was previously in grid-based, and now I will go to visualizations. That's where our annual glare report is saved. That's the annual glare HTML. You may remember that in that tutorial, in the third tutorial, this HTML file automatically popped up after running an annual glare analysis. So I'll just reopen this file just as a reminder. So here's our annual glare simulation report, and the base shading state, so with no dynamic shading and our unprotected south-facing facade, receives perceptible or worse levels of glare. Since it's facing south, it's between the hours of 10 and 2 p.m. and really peaking in terms of glare during the winter months and having some sporadic glare happening in the spring and summer months. And so the goal of this tutorial is to apply dynamic shading, apply a shading state to that facade to reduce the amount of red and yellow in this annual glare map. And then this again would correspond, when we run a daylight autonomy simulation, it will correspond to a lower glare probability, a lower amount of occupied hours receiving glare for this specific viewpoint. And we'll expect to see some trade-off in terms of daylight autonomy because we will be allowing less light into the space. And so let's go ahead and run and set up that experiment. So I'll go back to the Rhino file, and one of the first things that's important to note, of course we have to set a location and nodes. We've already set these two up in our file from previous tutorials, and you could reference those tutorials in order to go over how to set those up. But I'd like to show how the shading geometry looks. There's some shading geometry that's already built into this file. It is under the geometry group layer. If you scroll down, and you could see that there's a shading lowered layer that is by default turned off. And so I can go ahead and turn that layer on, and you'll see that that shading lowered layer contains a series of Venetian blinds that are modeled as individual surfaces. I'm in wireframe mode, but if I go to shaded mode, you'll see that these are surfaces that are placed in front of the south-facing window. And it's important that whenever you're doing a dynamic shading analysis in Rhino and in DIVA, you want to make sure that your shading geometry is fully contained within one layer, and that each layer contains one complete state of the shading. In our case, it's pretty simple. When I'm talking about state, I'm meaning, like in this case, whether or not the shades are fully up or fully down. A state could also be the rotation of the louvers. The rotation could be at 45 degrees in one state. It could be 180 degrees or 0 degrees horizontally in another state. But any state, any kind of a state where the blinds would be half up, then that entire group of geometry, all of the blinds half up, would have to be on its own layer called shading half up. And that's important because, as you'll see, we assign materials to these layers in order for DIVA to be able to send them properly to the lighting calculation engine. And also, in order to actually organize our shading control groups, each group has to have their own layer, and that's how we assign the dynamic shading control groups. So to keep things simple, in this experiment, we're going to just be doing no shading at all, and then shading lowered. But remember to fully contain all of your shading states within its own individual layer. So now that we have this layer in our model, the shading geometry in our model, I'll also just want to remind the listeners to always assign a material to that shading. The shading always has to have a material that is assigned in this assign materials tab in order for DIVA to properly send it to the lighting engine Radiance. So I go ahead and assign materials. This file already has the materials assigned for it. If I go down, this is of course organized by layer, and if I go down to shading lowered, you'll see that there is already a metallic material assigned to that. It's matte silver. And if you had various layer states, you'd also have to be careful to apply the right material to each layer state. So I can go ahead and submit the material information. And what I'll do first, before we do have nodes in the space from our previous daylight autonomy calculation, as you'll see, I could turn these on and off. I'll leave this off for now. First, I'll set up a annual glare analysis in order to see how we can visualize an improved glare situation from that same camera point that we used in the previous tutorial, now as a result of the shading that we have in our model. So before doing any analysis, we have to assign our shading control group. And so again, you'll click on the materials tab, and if you expand the materials pull down menu, you'll see that there is shading controls. So I'll click on shading controls. So in shading controls, by default, you probably will have this first tab showing up, which is no dynamic shading, and that's by default. When you don't have any shading in the scene, it defaults to this. The next tab is conceptual dynamic shading, which is a kind of it includes a kind of idealized blind that would be in front of a window. This is for a kind of faster and more simplified way of analyzing the effects of shading in a space. But since we actually have our shading modeled as actual surfaces in Rhino, we're going to be using the detailed dynamic shading, which is a more accurate way of evaluating the performance of shading on a window in your model. So you see that the first option under detailed dynamic shading control groups is to select nodes or select exterior nodes. Now we won't actually be needing to do this for this tutorial, but I'll explain what these nodes actually mean in terms of different types of controlling shading groups when I talk about the operation type. But first we'll look at the shading type. So the shading type, you can choose either mechanical or switchable. And in a nutshell, mechanical has to do with would be basically exterior or interior blinds that are mechanically operated, like the Venetian blinds that we have. They move up and down or rotate. It's basically geometry that can be dynamic and activated in terms of their mechanical movement. Switchable, on the other hand, would be if we had electrochromic glazing within our space. Let's say our window was electrochromic, meaning that when a current is applied to that glazing, it changes color. Or if a certain amount of light is hitting that glazing, it activates a current that changes the visible light transmittance of that glass. That's when we would select switchable. But since we are testing the performance of Venetian blinds in a space, we therefore need to use mechanical for this group. So the next step is operation. And operation is basically how DIVA will tell the daylighting engine whether or not shading is present. So what is going to be activating the presence of that shading. And for this tutorial, we'll be using manual, which is basically, it's saying that there's a user in the space that will, given a certain condition, whether it's direct solar radiation or the presence of glare, will activate the shading. So there are other ways to also activate shading, like automated thermal control and automated glare control, which rely more on the sensor nodes for having different kind of criteria for interior and exterior illuminance values. But I won't go into that for this tutorial, and you can check the DIVA online resources for more detailed information on those operation types. So as I said, we're going to be using manual. And manual operation really has two different ways of controlling shading. One is the presence of nodes, and those nodes will act as sensors within our scene. We might select one on top of our desk to sense for the presence of direct solar radiation. So if there is direct solar radiation, DIVA will then trigger the shading to be activated or closed. And if the solar radiation is not there, it'll be open. Now we're not going to be using that control type because we have been running an annual glare map, and we're interested in using glare as an indicator for whether or not shading needs to be present in the scene or not. So we're going to be using the second type to control manual shading, which is using the daylight glare probability file that we can create with this shading control group. So that will indicate if there is a disturbing amount of glare or worse based on the camera scene that we had chosen for the glare analysis, then DIVA will tell the scene to close the shading or to activate the shading. And so we do not need nodes for this type of analysis. If we're going to be using the annual glare map based on these shading control groups, we won't need to select any nodes, and we'll just go ahead and use the DGP file behind the scenes in order to dictate the presence of shading. And so how will DIVA know what geometry to use? Well, then that's the next two lines of this menu. So we have to assign a base geometry layer and then a glazing state layer. The base geometry is basically, so like, what is the baseline case where the shading is, let's say, either not there or open. Since we ran our annual glare analysis without any protection on the window, our base geometry is therefore no fixed shading. It's basically just the window without any fixed shading. And so you'll see that is by default selected, no fixed shading. It's a blank radiance file. There's no materials or any geometry assigned to in front of the window. We're just using the window. And then the glazing state layer, glazing state 1 layer is asking, okay, now what's the next state? So what's the next shading state? It's a little bit confusing because the menu is asking for a glazing state. That might have a little bit more to do with the kind of electrochromics. But for our case, since we're using a mechanical shading of Venetian blind, it's probably best to think of this as the shading state layer. And our shading state layer is going to be the geometry that we that contains the layer that contains the geometry for our Venetian blinds. And as discussed before, that is the shading lowered layer. And so I'll go ahead and click that. So you'll see that there is the option to add a state. So as I mentioned before, in our case, we're just using one state. We're using no louvers and then the shading lowered all the way. Let's say we had shading lowered only halfway. And so if we had created a shading halfway layer that contains a group of Venetian blinds that are half open, we would add a state and then select that layer for that state. And the best way to do this would be to create your glazing states from progressively moving from fully open to fully closed. So you'd want that half layer to be kind of in the middle. But since, not to confuse this too much, since we're only using one layer state, we're going to just keep it simple and not add a state and keep the glazing state one layer assigned to shading lowered. And now you can see that we can add a shading group or remove a shading group. So DIVA has the capability to have two independently controlled shading groups. And this can be thought of as if we had two windows in our space, we can have two groups. We can have one group of Venetian blinds on one window and another group on the other window that might open and close due to different levels of solar radiation if we had nodes, or different tiers of perceptible daylight glare probability at those different positions. Another way to think about this is that if we had only one window and we wanted to have two different shading layers in front of that window, let's say a series of Venetian blinds and perhaps maybe a series of larger rotating louvers, then we would add a shading group to have those two different layers represented in our model, and kind of those two different shading geometries have a dynamic role in the performance of reducing glare in our space. But since we're looking at a simple experiment where we're just using the shading, just one Venetian blind system in front of one window, we only need one group, and therefore we don't need to add or remove any shading groups. And so now that we're ready, we have all this stuff assigned, I'll go ahead and submit that shading group. So now DIVA now knows that we have a shading group in our model, and whenever we run a daylight autonomy metric, a climate-based metric, or if we run an annual glare analysis, it will recognize that we have a dynamic shading control group in our space, and it will consider the performance for each of those shading control groups. And so, as I had mentioned before, we're going to be running an annual glare metric first to see the annual glare map and its and the effect of shading on that annual glare map. I'm going to go ahead and click on metrics, and I'm going to go back to daylight images and annual glare. And we want to use the camera view. We want to actually use the same camera view that we ran our initial annual glare analysis for. And so actually I'll go back to the perspective view, and I want to go to named views, and I want to go to that row 1 west view that I used for our initial daylight, or our initial annual glare analysis. And you'll see that the shading shows up here. We're looking right out of that window. And I'll go back to metrics. And we can go back to daylight images, annual glare, and we'll use that current perspective view now that we have assigned this row 1 view looking west, or row 1 view, the first row, the desk on the west looking south. We're going to use that camera view for this current perspective view. The occupancy schedule, we're going to use the same schedule that we used in our previous annual glare analysis to have an apples to apples comparison. And it's very important to use the same radiance parameters that we used last time. If you remember, the only parameter that I changed was the ambient bounces. I set that to 4, and that's very important now because we have detailed Venetian blinds modeled in our space, and those detailed blinds are going to mean that more bounces are required in order for a camera, in order for like a sensor point inside the space to bounce off of the underside of the Venetian blind, and then bounce off the ground, and then maybe find either the sky or the direct source of light. And so having at least 4 ambient bounces is really important in order to properly evaluate all the different ambient bounces that are necessary for light to reach the inside of the space. So let's go ahead and keep that ambient bounce set to 4. I'll keep the adaptive visual comfort the same as I did for the initial annual glare analysis, that was set up as users cannot adapt. And I'll leave the geometric density and clean up temporary directory as the defaults. And I'll go ahead and run that simulation. And again, this is a very computationally expensive simulation type to run. It might take some time, and so I'll go ahead and let this run while I pause the tutorial, and I'll return once our simulation has completed. Okay, after the annual glare analysis has run, you should see an annual glare simulation report pop up, similar to the one that popped up during our initial annual glare analysis in the previous tutorial. So you'll see that the annual glare map for the base shading state shows up, and it gives you the name of the camera view that we used. And this is exactly the same as the analysis that we ran before. This is giving us the base shading state. And if we scroll down, you'll also see that it also has run an annual glare map for every other shading state in the file. And since we only had one other shading control group and one other state, we have only one additional glare map. And you'll see that for the same camera view, the shading group 1 eliminates all of the perceptible, disturbing, and intolerable glare for the entire year. And this makes sense because the angles of the Venetian blinds, when they're fully closed, they really inhibit the amount of direct light coming into the space and reaching the camera view. And I should point out that this shading group, the annual glare map that's resulting from the shading group, appears to be successful in blocking the annual glare from that perspective. There's no operation happening. There's no shades closing up and down. It's actually this is showing the annual glare map for the scenario where the shades are always closed. And so this is good because it's showing the capacity of the shading geometry for blocking glare from this viewpoint, but it doesn't tell us anything about the operational schedule that we'll need in order to open and close the blinds. And that's what we will do by running a daylight autonomy metric that will allow us to have a schedule for understanding when the shades are going to be open and going to be closed. Now let's look at the trade-off between glare and daylight levels. And so to do that, I'll go back to the Rhino file, and we'll go back to our perspective view that looks at the building from the outside, and we will activate the nodes again in order to run a daylight autonomy simulation to understand the impact of the shading on daylight autonomy distribution within the space. So to do that, I'll go back to layers, and I will go to the DIVA analysis surfaces layers, and I will unlock that, and I'll bring up the analysis grid. I'll unlock these layers as well. So you'll see that we have our results from our previous simulation. If I turn on the shaded view and turn off the roof layer as we did before, you'll see that these are the results that we got from our base case. And I'll turn the roof back on. You have to remember, if you ever turn off layers to help visualize some of the results within your space, remember, before doing another simulation, you always have to turn that layer back on, because if anything is turned off or locked within the Rhino layers, you will not be modeling those surfaces in DIVA. Radiance won't be looking at it. DIVA won't be able to send it to Radiance, and you won't get accurate results. So I'll go ahead and click on metrics again, because we're ready to run a different type of simulation this time. And now we'll move back to daylight grid-based. And we will look at climate-based simulations again. We'll run another daylight autonomy metric here. We'll have to use the same settings that we did before, so we again have an apples-to-apples comparison. So our occupancy schedule previously was 8 to 6 with daylight savings time at 60-minute intervals, and so I will keep that selected. Our target illuminance was 300 lux, 300 and lux was the units, and we want to definitely show the DASIN report. And here it's asking if we want to use the DGP schedules. So I'll hover over here and it says check the box to use an annual glare calculation result if it exists. I'll do that again. Note that shading options must be set before you run a DGP simulation for them to be used in controls. So we do have our shading controls submitted, and we do have daylight glare probability schedules in our local project directory, so I'll check that. And for the radiance parameters, again, this will remember the previous settings, but we want to make sure that we use exactly the same settings as before. And if you'll remember, I had set the ambient bounces to 4. And this is incredibly important again because we want to make sure that enough ambient light is reaching the sensors in the back of the space as a result of the kind of more granular geometry of the shading that we have in front of our window. And so we're going to keep it at the same value that we used last time, which was 4. For adaptive visual comfort, again, we want to use the same thing that we used last time, so I'll leave it at users cannot adapt. And again, for the remaining options, we'll use the defaults. So I'll go ahead and click Run Simulation, and we'll get a couple of prompts. So first it asks if we want to reuse our .dc files, and those are the daylight coefficients. So it's important to read this menu. This is something that has to be answered carefully. You could speed up your simulation by reusing these coefficients, but you can only reuse them under certain circumstances. So the menu says a daylight coefficient file already exists in the project folder. Should DIVA reuse these files for a significantly faster simulation time? Note, if geometry, materials, simulation parameters, or nodes have changed, you should select no. Well, our geometry has changed, actually. We added a shading geometry to the scene, which was not present in the previous run of daylight autonomy. So we definitely want to say no. We're not going to reuse the daylight coefficient file. We want to create new daylight coefficients. So I'm going to go ahead and select no. So it's going to run, again, the daylight autonomy, and this might take several minutes. So again, I'll pause the video while it is running. Okay, once the daylight autonomy simulation is finished running, we'll again see the Load DIVA Metrics dialog box that pops up. And again, it'll ask us which lighting test we want to run. We'll leave the default at daylight autonomy SDA, and it again indicates where the results file is located, and you'll see that it's located in the same place where we had saved our initial daylight autonomy file, but this time it actually indicates that it has detailed dynamic shading, whereas previously the file had no dynamic shading, and that's important to distinguish. So we can go back to those files after the fact, and we can reload them if we would like to reload the results, and we can tell the difference between the results without shading and the results with shading. And again, the visualization options ask us to choose a color scheme. I'll leave the default, and I always like to label all nodes, so I'll go ahead and check that, and we can load the simulation data. And so the DaySim simulation report pops up after loading the simulation results. And you'll see that the daylit area, which is the percentage of the floor area that's meeting at least 50% daylight autonomy with for the occupied hours with a target illuminance of 300 lux, is now 34% of the floor area. And now this is going to be a result of the shades being partially open and sometimes the shades being closed. And so you'll remember that from our previous daylight autonomy simulation that we ran in our second tutorial, and I have that DaySim report open here in my browser, we had a daylit area of 43% with an unprotected, unshaded facade. And now that we've provided dynamic shading, we see that there's a trade-off. Even though we were expecting to have reduced glare, the amount of daylit area is actually reduced from 43% to 34% of the floor area. And now I don't need to really go into some of these other report criteria, except you'll see that for glare, the percentage of occupied hours that are expecting glare is now reduced to 0%. And if you remember from the previous simulation report that I just clicked on here, from the unprotected case, we were seeing 16.7% of the occupied hours having glare, and we've reduced that to 0. And it also gives us a percentage of the occupied hours when our shading group is open, and that's at 61% of the occupied hours. And if I scroll down, you'll see that the report now also gives us a schedule of, or kind of annual map of the total hours of occupancy, and that was at 3,650 hours of the year. And you'll also see that there is a schedule for shading control, as well as a new annual glare map that is a result of the dynamic shading and its operation that we chose as manual. And we chose the operation without nodes because we had DGP schedules that was driving the operation of our shading. And you'll see here under shading control, so the system is manually controlled, which we had indicated, and it's according to the light switch model. And so with this, the light switch model is a sort of underlying algorithm that DIVA uses to run this manual control when we're using DGP schedules. And so this means that the system is being closed once the daylight glare probability is above 40%, or disturbing glare. And so this means that it assumes that the user can accept perceptible glare, which is between the 0.35 and 0.4 range, but it triggers the closing of the shades whenever we're in the disturbing glare range or worse. So whenever the DGP is greater than or equal to 0.4. And so you'll see that this shading group, it indicates whenever our shading is going to be closed. And so you'll see that on the scale, you'll see that the white color indicates when the shading is closed, and the blue is when the shading is open or unshaded. And you'll see that there is a kind of schedule that we get for that. And this also assumes that in certain cases, when the shades are pulled down, that they stay like that the rest of the day and also through unoccupied hours. And then when a user comes in the morning and there isn't glare, they open up the shade. And then below that is the sort of effective daylight glare probability annual glare map. And you'll see that it's mostly green with some splotches of perceptible glare. And what this is telling us is that there's no longer any disturbing glare or intolerable glare. All of the orange and red dots have been eliminated. And so you'll remember that from the annual glare map that we ran earlier in the tutorial, we were getting, for the unprotected case, quite a bit of disturbing and intolerable glare, especially in the winter months when the sun is at a lower angle. And now this effective annual glare map has eliminated all of those disturbing or intolerable glare. And we still have some specks of yellow because we remember that the system closes the shading once the daylight glare probability is above 40%. And whereas our annual glare map from our initial annual glare analysis was giving us two cases, it was giving us unprotected and protected. This is now giving us the resulting annual glare map after our shading group is selected and when our shading control is being selected. And so this is why we still have some yellow in the glare map. But what this tells us is that our shading geometry and our shading control is working successfully in order to eliminate glare in the scene. So thanks a lot. This about wraps it up for this tutorial. We covered how to incorporate detailed dynamic shading into our reference office scene, and how to run an annual glare analysis and a daylight autonomy analysis in order to evaluate the trade-offs of daylight autonomy and glare. And in the next tutorial, I will get into electric lighting and how to set up a scene with electric lights, and also how to evaluate light levels. So yeah, thanks a lot.